Section is going to cover the last new strategy that we're learning to solve a system of equations. So far, we've learned guessing and checking, we've done the graphing method, and last section covered the substitution method. This one is the last new strategy, which is called either the addition method or the elimination method. And we're going to explain why it has those two names. And I most often use the addition method as the name, and I'll explain why as we get through this section as well. So, as we go to the first topic, I just want to recap really quick what we've learned so far in this unit, which basically is if we are looking for a system of equations, and as you remember, a system simply means more than one equation. We want to find the point of intersection, and every solution is where the lines intersect. So everything we've learned in the last 4 sections has basically been covering the same thing with different strategies. And your job as a student is to figure out which strategy works best in most situations. I will tell you at the end of this unit, the most popular strategy is usually the one you're learning today. So what is the addition or elimination method? Well, I call it the addition method because all we're doing is we're taking our 2 equations and we're adding them together. That is the basis of the entire strategy. Now I'll explain in a second why it's also called the elimination method, but let's show basically what we're doing. Our goal is to simply add these 2 equations together. Well, 3x plus 1x is a total of 4x. 2y plus 1y is a total of 3y. And finally, 5 plus 2 is 7. All we did was add the first equation to the second. But now here's why the second name gets included. Our goal by doing this process is to eliminate one variable in the process of adding them together. But as you can see, just adding 2 equations together does not always eliminate a variable. So here is the one new step of this strategy. In order to eliminate a variable, and I'm going to pick eliminating x first, but it doesn't matter what you pick. What we need is we need the top number to be 3x and the bottom number to be negative 3x. They need to be opposite. And the strategy we can employ to do this is we're going to take this bottom equation and we're going to multiply every term by negative 3. And we're going to do that because we want this variable to be the opposite of that one. And I'm going to do that up here. Actually, let's do it on the side. So I'm going to rewrite 3x plus 2y equals 5 for our first equation. And then for the bottom equation, I'm going to do this thing every term times negative 3. 1x times negative 3 is negative 3x. 1y times negative 3 is negative 3y. And finally, 2 times negative 3 is negative 6. And now what we have is this equation just rewritten. And now we are going to go back to the addition method. And if we did it right, one of our variables should be eliminated. And there's why we have the 2 names. So if I draw a line down our equal sign, just to help me keep track, 3x plus a negative 3x is 0x, which is good. That's what we want. 2y plus a negative 3y is negative 1y. And finally, 5 plus a negative 6 is negative 1. And because we did it successfully, we eliminated our x's. 0 times x is always 0 and can be ignored. So finally, we have negative 1y equals negative 1. Or, if we divide both sides by negative 1, we know that the number y is equal to a positive 1. And because we found that, we can now find the value of x by plugging it back into any equation that we've worked with in this entire problem. I'm going to go back to this equation, and I'm going to substitute y as positive 1. So I get x plus 1 is equal to 2. Therefore, x has to be 1. So our question always asks, where do these lines intersect? These two lines intersect at the point 1, 1. We can check this answer by plugging these two numbers back into both equations and then make them both a true statement. I'm not going to do it in this video because by this time we've checked our answers repeatedly, and so we should be good at that strategy. So to save time, we're going to move on to another problem. For this problem, in order to find where these two lines intersect, we are going to be doing the addition method, which means we need to add these two equations together. The addition method is also called the elimination method because when we add them together, we need to make sure we remove one of the two variables from the problem. Well, currently, if I add these together, neither of the variables is going to have a coefficient of 0. Therefore, we need to change one of the equations. Personally, I want to make this so I have negative 4y. That's one of the ways we can solve this problem. I can do that by multiplying this top equation times negative 4. So 2x times negative 4 is negative 8x. Y times negative 4 is negative 4y. I already wrote that in there. And then finally, we have 4 times negative 4. That's negative 16. And now we can add these two equations together. And if I did it correct, one of the variables will disappear. Well, 3x times negative 8x, or plus negative 8x, sorry, is negative 5x. 4y minus 4y is 0. They are gone. And 1 plus a negative 16 is negative 15. I did eliminate one of the variables, so now I can solve for my value of x, and I get x equals positive 3. Now, to find the value of y, all I have to do is pick one of the equations that I've worked with, any point in the problem, and plug x in. So I'm going to go to this one, but you could go to any of them. Well, I know that 3 times x, well, x is 3, plus 4y has to equal 1. 3 times 3 is 9. 9 plus 4y equals 1. We're fine here. And I'm going to subtract 9 from both sides. So I get 4y equals negative 8. And then I divide both sides by 4 to get y equals negative 2. So the question asks, where do these two lines intersect? We know that they intersect at the point 3, negative